Hey everyone, in this example demo, we'll be going through how to do a small section of a large lot subdivision within Neara Designer. We'll be starting with an empty model file with a DXF overlay already uploaded. This DXF has the proposed lot boundaries from our developer, and we can use this to help plan our network. Again, this design and DXF will be available from our Fresh Test website if you want to download and follow along. For this tutorial, we'll only be modeling the proposed LV network. In the future video, we'll be going through how to connect the HV cables from an existing model, such as from AutoMod, and how to connect open links to LV feeders for emergency voltage drop calculations. Looking around our design with the Google Satellite overlay, we can see that these streets have already started being built. But changing to the DXF overlay, we can see how the lots have been divided by our developer. For this project, we'll just lay the LV network for the first two feeders of this substation, which supply mainly these two blocks here. But you could continue this design and model the other feeders as well. I just want to note that this is just a recommended workflow for an example project to help you get familiar with the tools. Feel free to use a different workflow if it integrates with your design process better. The easiest thing to do first is to place down all the nodes for our design. We can start by placing a substation near this intersection here between Ashlar and Field Street, where our developer has allocated space for us to put the subs. We would then place pillars at the general locations, ideally on the property boundaries between houses. These would ideally be 4 houses apart, so then we can then service 4 houses per pillar. These are not finalized locations, and the pillars can be moved at any time, but this gives us a better idea of our network. This would also be a good time to attach the service points to each of the pillars to their houses. I'll just go through our project right now and add these in. Once we have all our nodes, we should start connecting cables between them. A possible option would be to start using the cable tool and connect the substation secondary to a pillar like so. And you would continue this so on from pillar to pillar. But as you can see, this would connect the substation to the pillar in a direct line. To control the route that the cable actually takes to the pillar, we should create a trench and trench section across the road. By clicking on the cable, we can go to the Properties tab and add a new entry for the cable placements, selecting the trench section that we just placed and choosing the placement. However, this gets pretty tedious if you have to do this for the whole design. The easiest way to do this is to first place the trench sections before the cables. So to do this, we're just going to add trenches along the front of the property boundaries, making sure that all the pillars are connected. Underneath the trench tool, we're going to specify the cross-section type as none. And we're going to place the trench section waypoints at each property boundary, just so it follows the curvature of the road. Again, for the sake of time, we're only going to do this for 2 feeders of the substation, and I'll just go ahead and place these in. Next, we're going to place trench sections between all our pillars. I'll just explain the reason behind all this as I add in all the temporary sections. The reason why we place in temporary sections between the pillars is so that we can guard the cable. Later on, we can actually specify the actual section that's going in that trench and change the placements of the cables accordingly. Adding in the sections this way also allows us to have separate sections between each pillar. This is so later on, we can specify that the section between pillar 1 and 2 might be a 2x2 conduit, for example, while the section between pillar 2 and 3 might only be a single direct buried cable. If we were to use the trench section tool with the default trench sections, this would have placed a single section between pillar 1, 2, and 3, meaning they would all have to be the same section. Once all the trench sections are in place, we can go back to the cable tool, making sure that we are using the correct cable type and setting the cable voltage to 0.415 kilovolts for this network. We can then go along our design and connect the pillars as required. You can see that the new trench sections are added to our placement table as we hover along the different trench sections between the pillars. At this moment, we're just going to check our network in the plan view and enable the visualization of the voltage drops. We can see at this section of our design, the voltage drop is over 10 volts. We should fix this accordingly. We're just going to delete this cable here and connect it through this street here so that we hopefully get a lower voltage drop. Once we have a basic layout of the network, we can go through each section and change the appropriate trench section, as we have multiple cables going into a single conduit of the trench sections currently. So for this road crossing trench from the sub here, we're going to click on this blue cross here to edit the trench section and change the cross section type to a 2x2 conduit. All the cables that we've placed so far are still in placement 1. So we should click through each cable and assign the appropriate placement. So these 2 cables here going towards the east will be changed to placement 2 and 4, while the cable going west will remain in placement 1. Zooming out a bit, we can see that we now have 3 cables, each in their own conduit. Another thing that we might want to do is have a mix of sections between 2 pillars. So going west from the road crossing, we might want to shorten this 1x1 conduit that's going towards this pillar and place a new trench section here with preset 2. So we can have the 2 cables in direct buried slots with a spare conduit as required. We're going to keep going and changing the sections as required for the rest of our design. And I'll just do this now. The last feature I want to show is how to model trenches with changing depths. Going back to our road crossing trench next to the substation, we might be required to underbore underneath this existing road. To change the depths, we should add 4 trench waypoints along our trench. 2 points will be used to specify the top of the underbore, and the other 2 points for the bottom. Starting from the substation side, we can click on this waypoint and change it to a vertical waypoint, meaning that the X and Y locations are ignored and the point has to be inline to the trench. We can see that the conduits have risen up to the surface, and this is because our ground offset is currently set to 0. We should change this to -0.6 to match the existing trench level. We continue through and change the middle 2 points to a vertical waypoint as well. And for these, we'll change the ground offset to -2 meters. The 4th point should be similar to the first and set to -0.6 meters. We can then move these waypoints along the trench to dimension the slope of our underbore appropriately. So in this case, maybe we'll set the waypoints to be 2 meters apart for our slope. Lastly, we can do a check that all our voltage drops are under 10 volts and our cable pull tensions are within the limits. We can change our model at any time if these checks are failing. It's also possible to create automated reports that can check that the voltage drops are under the specified limit or check that the cable tensions are under the specified material strengths. These automated reports can then flag up the violations as required. So this concludes our tutorial 3 for a large lot subdivision. I hope you guys have enjoyed this tutorial and have fun designing on Neara Designer.